you everybody who is watching this session or this lecture 7. Very happy to have you, whether you are a national or international viewer. You're warmly welcome, and I'm very happy to have you today. My name is Olenjolai TAYAI. Simply just call me Olenjolai. I'm from Tanzania, eastern of the African continent. This is our national flag, right? It's a beautiful country, and I would like to welcome all the viewers, whether you are a national or international viewer, to visit our beautiful country. I would like just to welcome you and spend a couple of the minutes to remind you the vision that we have. I would like to welcome you into online Undergraduate Polytechnic Institute of Tanzania (OLENJOLAIM). Simultaneously, I would like to welcome you into one of our YouTube channels that's called the Online Undergraduate Polytechnic Institute of Tanzania (OLENJOLAIM). Well, what are we doing in online Undergraduate Polytechnic Institute of Tanzania (OLENJOLAIM)? Well, we have an assignment which it can be divided into 4 parts. This assignment we've been given by our Father who is in heaven, and I have an assignment to teach, to incubate, to train, to encourage, to mentor, and even to lead some group of students who will be ready to take the classroom instructions in fundamental modules or courses. When I mention about fundamental modules, including the mathematics and some related courses, combining with the knowledge from the core courses in engineering or science, for undergraduate students who will be ready to take the classroom instructions in fundamental and core modules or courses, to combine with the knowledge of the Word of God from the Holy Bible in order to solve real-life problems. So that's our visions has 4 parts. Number 1, first of all, to master or to extract knowledge from the classroom instructions in fundamental and core courses or modules, right? Number 2 is to understand the knowledge or to extract knowledge from the Word of God that treats in the Holy Bible. And the 3rd part is to combine these 2 knowledge. And the 4th part, to solve real-life problems. Right? Myself, I'm a product of the knowledge of the classroom instructions in undergraduate, in engineering courses or in engineering course, one of the course or engineering program. And also I'm a product of the Word of God, right? Of the knowledge or knowledge, understanding, and wisdoms of the Word of God. So, and I'm always trying my level best to combine these 2 knowledge. And my focus, or my primary focus, is solving real-life problems. So that is all. So that's the point that you have to make sure that we have take into consideration. So I would like to invite you. We have our main objective in this, in online Undergraduate Polytechnic Institute of Tanzania, is not to help students to pass exam. That's one of our specific objectives. Our main objective is to see our continuing and even graduate undergraduate students or bachelor students solving real-life problems from their community, even a small scale real-life problems. So you can solve, if we categorize real-life problems, there are different categories. So we'll be happy to see that at least you are solving 1 or 2 or 3 real-life problems. That's our main objective in this platform. We have so many specific objectives. One of the specific objectives, we like to see our students, and even we like to teach our students by using a simple language and even a simple way and simple techniques and simple teaching aids, so that our students master and love the best subject of higher engineering and scientific mathematics, right? For all the 2 years of undergraduate studies. Another specific objective, we like to help all our students to master and even to do well and do excellent in their continuous assessment, testing, and even maybe homeworks and etc. In the classroom instructions. We'll be focusing too much on the classroom instructions at this moment, because we know that we want to reduce stresses and even reduce confusions and even panic from our students. So we need also some weapons. We need to have reference books, as I've mentioned in session or in lecture 00, the general introductions of calculus, right? Calculus, you have to make sure because you still have that video. But another weapons, because there you should have textbooks, whether soft copy or hard copy. Second weapons, you should have questions and answers book, right? Questions and answers books, just like reference books. And the third weapons, you should have the scientific calculator in case that you don't have a certificate, original certificate calculator, we are not only teaching students, but also we are providing original and we are providing materials to help and assist our students to go far as well as they can. So in online undergraduate Polytechnic Institute of Tanzania, we are also selling original certificate calculators. Okay, so that's the very important piece of information. I think that now you have the, even more than, I think you have got these little introductions for the benefits of your life. So let us go into the session, into the desired lecture. This is lecture 7. We have some departments in online undergraduate Polytechnic Institute of Tanzania. One of the departments is called the Higher Engineering Scientific Mathematics. And also the course that we have today is called Calculus, and this is by the reference of the NACTE syllabus and the Dar es Salaam Institute of Technology, right? And this is the first topic or chapter 1, we call the theory of limit. And I'll let you do a quick review of lecture 6. This is the second subtopic called formal definition of limit, and this lecture 7, formal definition of limits, will be solving problems. And this goes in Tanzania, and especially that many institutions are enacted, which is the long term is National Council for Technical Education. It used to be studied in the first semester and also in the first year, right? In many institutions of the Republic of Tanzania. Wow. So let me do the quick review of lecture 6. Basically, the first thing which I told you is all about formal definition. And I told you that formal definition, this is the present definition of of limit, right? And then so we define it geometrically, we define it algebraically, right? So algebraically, we say that given a limit of the function as x approaches to a, f of x is equal to r, right? Then we say that for every epsilon greater than 0, for every epsilon greater than 0, there existing delta greater than 0 such that if 0 less than absolute of x minus a less than delta, then we say that absolute of f of x minus limit, this is also less than epsilon. So this is the formal definitions of limit of the function. And then I did the example, I did 2 questions, and I left 1 at the homework. I did example 12, I did example 11, and example 12. I left example 13 at the homework. So it has been very interesting concept. We can also present it geometrically. So geometrically we say that, suppose that we have a certain curve, which is f of x like this one, and then this is the x, or this the point which is x is equal to a. So this point we can call it limit of the function, right? So this is the limit of the function, and when you come to this point, this is called the a minus delta, and then here it is r minus epsilon. Against that we have this point, right? So this is a plus delta, and then here it is r plus epsilon, right? So that's the point that we have to make sure that we take into consideration. So right now in lecture 7, we say that let us do correction. So correction of lecture what? Corrections of corrections of homework, not lecture, of homework 5, homework 6. Okay, homework 6 was example 13. Okay, so the questions was stated like this. Example 1, 2, 14 into, so this is the example 14. Example 14. Okay, prove that limit as x approaches to 10 of the certain function 3x plus 4, this is equal to 35. That are the questions that will be given. So you have to make sure to solve it effectively. So prove that limit of the function 3x plus 4 as x approaches to 10 is equal to 35. Solution. So I believe that you did this question, right? And you submitted your homework, or if you didn't do, please, you have to check the prerequisite of lecture 7 is lecture 6. Remember that. And let me repeat, the prerequisite of lecture 7 is lecture 6. You have to make sure that you learn and you cover lecture 6 before lecture 7. Solution. So the first step, we say that we call the formal definition of limit. Call the formal definition of limit, right? So the formal definition of limit, we say that, or say that given limit as x approaches to a of f of x is equal to r, then we say that for every epsilon greater than 0, right? For every epsilon greater than 0, there existing delta greater than 0, such that if 0 less than absolute of x minus a, then less than what? Delta, right? Less than delta. Then absolute of f of x minus l less than what? Epsilon, right? So then we go for the second state, that the first state. The second state, we say that compare the given function FCT with general formula of formal definition. So if we do compare, it means that here we'll be given limit as x approaches to 10, and hence the function is 3x plus 4. This is equal to 35. We have to prove it. So, but we'll be given the general formula state that limit as x approaches to 4. Then here we have function f of x is equal to r. So if you compare, a is equal to 10, and then the function f of x, this is equal to 3x plus 4. Then the limit of the function is equal to 35. That's the second state. Then we go for the third state. The third state, we say that substitute values of a, f of x, and the r in general formula. So if you substitute, we find that 0 less than absolute of x minus a is 10, less than what? Delta. This implies what? Absolute of f of x. What is f of x? It is 3x plus 4. minus L. L is 35. 3 plus 4. Let me check. It's 5. Excuse me. This is 5. So it's 5. So here it is 5. Okay? And here it is 5. Okay? So here it is 5. And this is less than epsilon. Okay? So you say 0 less than absolute of x minus 10 less than delta. This implies what? Absolute of 3x minus 30 less than epsilon. This is equation 1. That is equation 1. That is equation 1. So then we go for the third step. So the third step, we say that consider right hand side of equation 1. Consider right hand side of equation 1. So the right hand side of equation 1 is absolute of 3x minus 30 less than epsilon. So let us take 3 out of the bracket, which is absolute of 3, and x minus 10 absolute is less than epsilon, right? Absolute of positive 3 is equal to 3, then absolute of x minus 10 less than epsilon. So then we divide by 3, we should divide by 3. We have absolute of x minus 10 less than epsilon over 3. Right? So that is the steady state. Then we say that, okay, fine. So we go for the first state. So the first state, if you consider the right hand side there, the first state, enjoy the beauty of higher engineering mathematics. The first state, it means that we can realize that absolute of x minus 10, which is less than what? Delta. This is equal to delta. So we can choose. Right? We can choose that delta is equal to epsilon over 5. Epsilon over 3, excuse me. Epsilon over 3. 10. Okay. So then we say that, okay, so we say that this is epsilon over 3. So if that's the case, we say that, okay, fine. So we go for we say that we consider this factor now, consider right hand side of 40 of equation 1 here. So we have absolute of 3x minus 30 less than epsilon. Remember that I told you in lecture 60 that the formal definition of a limit is closely, or this the one of the concepts that we deduce from pure mathematics, right? From higher pure mathematics, right? So it's a kind that we'll be using later, and sometimes that you can see easily the concept behind that what you are doing. Okay. So then we say that for this case, say okay. So you can take absolute of 3 also, because it's common out of the bracket. Here remains is x minus 10, and then this is less than epsilon. So absolute of 3, it is 3. then absolute of x minus 10, this is less than epsilon. Okay? So, but I have told you that absolute of x minus 10, this is equal to delta. And this delta, we took it is equal to epsilon over 3. Right? So if that's the case, you say that 3 times epsilon over 3, this will be equal to epsilon. And this is true. If you simplify, epsilon is equal to epsilon. Hence shown, hence proved. Hence proved that the limit of the function, here it is x approaches to 10. There we had 3x plus 5. This is equal to 35. It's equal to 35. That's the response of that question. Okay, so that was the corrections of example 14. Ladies and gentlemen, let me take you into example 15. Example 15. Prove that limit as x approaches to -3 over 2, limits of the function 1 minus 4x, this is equal to 7. Is equal to 7. That's the question. We have to prove that limit. Okay, so this we can have notation like it's a concept. We have to prove that limit of the function 1 minus 4x as x approaches to -3 over 2 is equal to 7. Can you try? You can pause the video and try on your own. Right? Because this is the first example of formal definition. I've prepared 6 examples that I'm going to solve for you. Okay, 6 examples. 6 to 7 examples, I think so. Okay, so solution. So trust on your own, right? Trust yourself, right? The first step, I told you we have to recall what? Recall the formula of formal definition of limit. Okay? So this formula states that given limit as x approaches to a of f of x is equal to r. Okay? So we say that for every epsilon greater than 0, they are existing delta greater than 0. Delta greater than 0, the existing delta greater than 0, such that if absolute of f of x minus L, this is less than epsilon. Now, such that if 0 less than absolute of x minus a less than delta, then absolute of f of x minus r less than absolute. So that's the first definition. That's the first step. Then we go for the second step. The second step, we say that we have limit of the functions at that point. Okay? So then we say that compare the given function with the formula. So if you compare a is equal to negative 3 over 2, the function f of x is what? 1 minus 4x, and the limit is equal to 7. Okay? So after comparing, then now we know the value of a, value of f of x, and the value of limit. We go for the third step, as I told you. Substitute. Okay, substitute values of what? Of a, f of x, and r, and the formula. Okay, what the formula? The formula is 0 less than x minus a less than delta. This implies that absolute of f of x minus r less than epsilon. So this will make 0 less than x minus a. What is a? A is negative 3 over 2. Okay? Less than delta. Okay? So this is f of x. It is 1 minus 4x minus r, which is 7. Less than delta. Less than epsilon. 0 x plus what? 3 over 2 less than delta. Then this one is 1 minus 7. This will make negative 4x minus 6 less than epsilon. This is 0 less than x plus 3 over 2 less than delta. Okay, so this will make OT, will make negative 4. Okay, so you can take negative, okay, so you can say that, okay, negative 4x minus 6 less than epsilon. So this is equation 1. Okay, after having question 1, I believe that you enjoyed the field of higher engineering and scientific mathematics. So we say that consider right hand side. So this is really the first step. Consider the right hand side of equation 1. So the right hand side of equation 1 is negative 4x minus 6 less than epsilon. So take negative 2 out, absolute of 8, and then here you remain with 2x plus 3, right? Less than epsilon. Okay. So to have what we have here, x plus 3 over 2, right? We can keep on taking 2 out. So we can take 4. So then negative absolute of 4. And then so here we remain with x plus 3 over 2. So if you expand it, we still get the previous equation, right? So as I have written this, the conceptual question. Absolute of 4, this is equal to 4. Then this is x plus 3 over 2 less than epsilon. So we can divide this 4, we can divide this 4. So then absolute of x plus 3 over 2 less than epsilon over 4. Right? So then, so if that's the case, we say that we go for the fused state. Remember that in previous example, second step and second state has been combined together, okay? So the fused state, we say that from that equation, we say that absolute of x plus 3 over 2, this is equal to delta, right? So that we can choose, delta is equal to epsilon over 4. So you can choose delta is equal to epsilon over 4. So remember that we are proving the limit of a given function. We are not finding the limit of the function, but we are proving. So then afterwards, after choosing this one, we say that, consider the right hand side again of question 1. So the right hand side, it was negative 4x plus, not plus, minus 6, absolute less than epsilon. Right? So again, we say that take negative 4, absolute of 8, this is x plus 3 over 2, less than epsilon. So the absolute of negative 4 is equal to 4, and then x plus 3 over 2, less than epsilon. So now, we don't divide this equation by 4 to both sides. But what we say, remember that we said in the third step, in the fourth step, x plus 3 over 2, this is equal to delta. So therefore, 4 times delta, this will be equal to epsilon because it's less than, right? And hence we chose the value of delta to be epsilon over 4. So this is equal to epsilon. So hence, shown or proved, if it is the question was asking. Hence proved, that the question was asking to prove. Hence proved that the limit of the function, which was 1 minus 4x, as x approaches to negative 3 over 2 is equal to 7. All right? If you have any question, don't hesitate to ask in the comment section below, and I'll try my level best to answer your question. Okay, so now let me take this opportunity to give you one of the challenging questions, and then I'll leave a homework for you. Okay, because I believe that now you are competent enough in these concepts of the limit of the function. You are competent enough in finding the limit of the function. We may solve the conceptual question, and this will make example 16. Example 16, and this is concept. You can refer this example 16 for the, I took it in from final exams of DIT, refer DIT, Dar es Salaam Institute of Technology, final exam or university exam. FA is abbreviation of final exams or university exam of 2017-18. Okay, question 2 was question 2, Roman A. Question 2, Roman A. The question states that use epsilon delta definition of limits to verify that limit as x approaches to 2, then this is 4 x squared minus 4 divided by x minus 6, not x minus 2. This is equal to 16. Okay? So regardless that you are watching this video from Egypt or from India or from Indonesia, this is the common questions worldwide. So you can meet with this question in any institution as long as you're learning the concept of theory of the limit. So that's the question which, if you solve, will be awarded 6 marks. In most cases, you find that the concepts of limit, the concept of formal definitions is tested or is being asked in section B of the university exams or final exams, which compare this actual so many marks compared to section A. So use, this is epsilon, this is delta, these are the Greek letters as I told you in the beginning. Definitions of the limits to verify that. So you have verified that limit of this function 4 times x squared minus 4, or 4 open bracket x squared minus 4 close bracket over x minus 2 as x approaches to 2 is equal to 16. If you do it by that time, the students will be awarded 6 marks, right? Okay, so solution. Okay, solution. So you say that the first step, we say that, recall, for this question now, we have first of all, because this is a rational function, this is the rational function, numerator, denominator, we have to think on how we can simplify, right? Before we recall the general formula of the formal definition of the function, we have to simplify the given function. So the first step says that simplify the given function. Okay, the given function. What the given function? The given function is f of x is equal to 4, and you have x squared minus 4 of what? Over x minus 2 first. This is 4. Okay. So we say that x squared minus 4, this is forming difference of 2 squared. So it is x squared minus 2 squared, right? So from the concepts of difference of 2 squared, a squared minus b squared, this is a minus b, a plus b, right? So if that the case, you say that x squared minus 2 squared, this is equal to what? This is equal to x minus 2 and x plus 2. Right? So if that the case, we say that suppose that this is equation 1 and this is equation 2. Right? So I say that the second step, we say that substitute equation 2 in equation 1. So if you substitute it, you find that this is f of x is equal to what? Is equal to 4, then x minus 2, x plus 2 divided by x minus 2. So we can simplify numerator and denominator. So then we get our new function, which is, we call it the new simplified function of x. New simplified function of x, which is f of x. This is equal to what? Is equal to 4 x plus 2. But no any denominator. No any denominator. Right? So we can even further simplify and have for x plus what? Plus 8. So this is our new function. So you go for the third step. Don't claim that the function which should be given in this concept will be only linear functions. It can be rational. You can be given a rational function, and you have to think even beyond what if you be given a quadratic function. So you have to think, and you have to use fundamental concepts of mathematics in case that you find that the functions is not the normal functions as you've been learning this concept. Okay. So the third concept now we say that we call the formula of general or formal definition. Formal definition. Called the formula or formal definition of what? Of limit. Okay. So the formula states that given limit as x approaches to a, then f of x is equal to r. Then we say that 0 is less than absolute of x minus a, means that minus a less than delta. This implies the absolute of what? So we say that for delta greater than 0 and epsilon greater than 0. So then we say that this implies what? F of x minus r less than epsilon. Right? So if we compare, we just do straightforward. A is equal to what? From the given function, a is equal to 2. F of x is equal to 4x plus 8. Then limit of the function is equal to 16. Right? Good. So then we say that we go for the first step. The first step, we say that substitute values of what? Of a, f of x, and r in formal definition. Okay? How? So we say 0 less than x minus what? A less than delta. This implies that f of x minus L less than epsilon. So 0 less than x, what is A? A is 2, less than delta. This implies what? F of x, it is 4x plus 8 minus 16 less than epsilon. So this is equation 1. Or this is equation 3. No, this is equation 4 because you have equation 3. This is equation 3. This is equation 4. So then we go for the fifth step. the fifth state, okay, say consider right hand side of equation 4. So to consider right hand side of equation 4, we say that we have absolute of 4x plus 8, no, minus 8 now, if you simplify, less than epsilon. So we can take absolute of 4 out of the bracket. So here remains x minus 2 less than epsilon. Right? You have to enjoy the beauty of higher engineering and scientific mathematics. So absolute of 4 is 4, so we have 4 x minus 2 less than epsilon. So you divide with 4, divide by 4. So absolute of x minus 2, this is less than epsilon over 4. Okay? So once we are there, we go for the sixth state. The sixth state from that equation 4, say absolute of x minus 2 less than epsilon, less than delta, this is equal to delta. So now we, as mathematicians, we can choose what? Delta is equal to epsilon over 4. Okay? Epsilon over 4. Epsilon over 4. Okay? So in this case, we say that, okay, so we can also consider, after choosing that, we have to consider again right hand side of equation 4. If you consider right hand side of equation 4, this is absolute of 4x minus 8 less than epsilon. So you have absolute of 4. This is x minus 4, x minus 2, excuse me, absolute less than epsilon. Absolute of 4, it is 4, x minus 2 less than epsilon, right? So, but we say that x minus 2, this is equal to delta. So 4 times delta, this is equal to epsilon. We chose 4 delta is equal to epsilon over 4 here. This is equal to epsilon. So hence, the questions was asking us to prove or to show. Hence verified. Hence verified. Okay. So then, before I end this session or this lecture 7, I would like to leave the homework, which will be homework 7, and it will be the end of this part, of the first part of formal definition. And as in the lecture 8, I will begin to teach you, I'll introduce to you a concept that we call finding deltas algebraically for given epsilons. Very interesting and very important concept. So this is homework 7. You have to make sure to do it. But in our list, this is example 17. We've done 16 examples of limit of the function. And this also question, I took it from one of the reference, which I mentioned that past papers are very important reference. The IT final exams, okay, university exams, but remember that the question you can meet with it worldwide in any institution or any university in the world. So in this year, it was question number 1A, right? So it's very interesting questions. It states like this one: use epsilon delta definition. Use epsilon delta definition of limits limits to prove that. Prove that the limit as x approaches to true of the function which is 3x minus 2 is equal to 4. This, if you do this question, you will be rewarded 3 marks. I don't know about your teacher. Questions state that use epsilon delta definitions. Whenever you see epsilon delta definitions, it means use formal definition of limits to prove that the limit of the function of the function 3x minus 2 as x approaches to 2 is equal to 4. That's all. So this is the end of lecture 7, which has been titled as Problem Solving in Formal Definition of the Limit of the Function. I thank God who have created me in his image and likeness. I thank God also who have given me a gift of teaching, right? He built his gift of teaching in me as flying, as he has built it, flying in birds. I would like also to thank God who have given you a chance to be with me. And I would like to thank God who have given me this generational idea of teaching present and future generation the beauty of higher engineering and scientific mathematics so that they can learn and cover it intensively. I would like to invite you in lecture 8, when I will teach you against another concept where I will teach another concept of finding delta when we have been given the value of epsilon. So remember that epsilon corresponding to the value of y, and delta corresponding to the small increment in x value, right? So make sure you join me and don't miss it. I will take you from one point to another point in that lecture. So keep on reviewing all the 8 lectures, because we have lecture 00, lecture 01, lecture 1, lecture 2, lecture 3, lecture 4, lecture 5, lecture 7. So in total we have 8 lectures of calculus for undergraduate students. So make sure to review, you go through them. In case you have any question, ask in the comment sections of that video. Share these contents. Remember to subscribe. In case also you will feel from your heart that you want to offer God a free willing thanksgiving in order to support this program, you may send it through this telephone number 0759745331. And in case you want to bank transactions, just go to the descriptions below and you see that how much and you see the bank name and even that the account name and account number, which the bank name says NNP, right? So your free willing thanksgiving will be received with honor and with fear of God, and will be used effectively to make sure that you are 10,000, but no, just mean that more lectures of calculus will be in air, because I hope to make sure that I upload or I add more than 50 lectures of calculus in our YouTube channel. But remember that also in online undergraduate Polytechnic Institute of Tanzania, we are teaching almost 12 courses or 18 modules. So it means that it's very expensive, the running cost is high, but our God is greater than the running cost. So I'll keep on praying for you, and I'm always praying for you. Pray for me also, and I would like to invite you in lecture 8 of formal definitions. Will be still finding delta for given value of epsilon, right? So may God bless you. Make sure to review, you do the homework, submit the homework before in the comment section before we meet in the next session. May God bless and keep you safely until we meet. I love you so much.